What we're going to go over tonight is the basics of VRF systems. We'll learn something about the individual components. We'll learn about some of the particulars in installation and a basic overview of heat pump versus heat recovery. Now, VRF systems, the number one rule in this page on um, the Daikin's manual, and we're going to be going over Daikin mainly, only because I have their guides available for us to look at. But most of what we're going to go over is going to apply to all VRF systems. All right. The first rule is get training on the individual manufacturer's equipment that you're working on. Whatever the equipment manufacturer you're doing is, whether it's Daikin or Carrier or Mitsubishi or LG or so on and so forth, you need to get training on that particular manufacturer's requirements before you do any installation of the equipment. If you have not been trained but you're helping on a job, then make sure you consult somebody who's had training before you do anything with the equipment, because every manufacturer has their quirks when it comes to VRF systems. And if you follow the rules from one manufacturer on another manufacturer's equipment, you may end up in a situation where it doesn't work properly. Quick case in point, if you're working on a Daikin system, all the wiring is two wire, not shielded. Don't really have to worry about too much. It does require stranded wire, but it's not shielded or anything. Unless Carrier's changed anything in the last few years, Toshiba Carrier, then they require shielded wire grounded on one end for all their communication. So if you put in wiring like it's a Daikin system, and you don't have shielded wire that's grounded on one end, and something doesn't work, they're going to tell you it's because you installed it improperly, whether it would actually cause a problem with operation or not. And that brings another large point when it comes to VRF installation. Do it carefully and do it right, following their instructions. Because a big problem you can run into is the fact that these are generally very large systems, anywhere from 30 to 120 tons. And if there's a problem, especially with all this refrigerant pipe that we're going to be looking at that you end up connecting, it can add up to almost a mile of refrigerant pipe sometimes. And if there's any issues with the system and a compressor goes bad or something like that, then a lot of times, if there's anything that they can blame on the installation, then it's going to be your dime that fixes it, or your boss's dime. And it can get very, very expensive very, very fast. So you need to make sure you're doing everything properly. What I like to say is you want factory quality work every single time. That means you purge while you braise, you follow good piping practices, you close up the system when you're done at the end of the day, you terminate your wires properly, you make sure that you don't have any connections that you can't get to later. Um, all those little things, you know, do it all to the best of your ability, because the last thing you want to have is a large system with copper shavings in it, or a bunch of oxidation from brazing in it, and it causing problems on multiple units, and you having to foot the bill of making all the necessary repairs to the system. So it's extremely important when it comes to these systems, that you do everything the way it's supposed to be, exactly by the book, no cutting corners, because you do not want to be responsible for any um, malfunctions in equipment operation. They say that 95% of all equipment failures are installation error in one form or another. That may or may not be a little bit of an overstatement, but it generally does hold true. And again, when you're talking about a large, complex commercial system, you do not want to be the one who made critical errors in the installation or commissioning of that equipment. So, those are your two big rules you should remember right off the bat. You want to follow manufacturer's instructions and you want factory quality work every time. And the last one, I guess, is make sure you get trained, but you should be getting trained regardless. And that's part of manufacturer's instructions. All right. So, again, we're going to kind of flip through some of this Daikin stuff and I'm going to talk about individual points when we get there. But, most of what I want to cover uh, is going to be universal across VRF systems. Now Daikin calls their stuff VRV. Throughout this manual, you'll see VRV instead of VRF. All right. VRF is variable refrigerant flow. VRV is variable refrigerant volume. Um, for all intents and purposes, without going into Daikin marketing information for the most part, they're exactly the same. So anytime you see VRF or VRV, we're talking about the same kind of system. We're going to learn about those systems now. So, um, let's go through the individual components of a VRV system or VRF system, and let's talk about what they are. And most of these things should be relatively familiar and for any AC or heat pump system. And you'll see that it looks a little more like mini splits than anything else. But it's basic stuff. So you got outdoor units. Real quick, point number one, heat pump outdoor units. There's no straight AC VRF system. You have heat pumps and you have heat recovery. Most of what we're going to cover is heat recovery because it's more complicated than the heat pump. And if you understand the heat recovery, you'll understand the heat pump. The difference between the two is not really the outdoor units. So let's just look at these pictures real quick. They have 6 tons, 8 and 10 ton units, and 12 to 14 tons. So those are their individual units. For Daikin in particular, you have one compressor, two compressors for these different unit sizes. Most VRF units are going to have 1 or 2 compressors in each outdoor unit, as you can see here. So these are heat pumps. Here's a better picture of what they actually look like. And then you can see how you can combine these to create bigger systems. So, oh no, sorry. These are single and manifolded single outdoor units. These are triple modules. And you can actually take, say, 3 of these 14 tons and make a bigger system. When you get to heat recovery, they look the same, right? Heat recovery units, outdoor units look exactly the same as heat pumps for the most part from the outside. Difference between heat pump and heat recovery. On a heat pump system, you're going to have 2 pipes, and we're going to get into the piping in a little bit. But the main thing you got to remember about heat pump and heat recovery is on heat pump VRF systems, you have a 2-pipe system. So you're going to have a liquid line and a suction/discharge line, just like any other heat pump. There's nothing different there, or just like any other, mini split style heat pump for the most part. On a heat recovery, you're going to have 3 pipes. So real quick now, the 3 pipes are liquid line, low pressure gas, high pressure/low pressure gas. Okay. So you always have a liquid line no matter what. You have a low pressure gas, which is your suction line, and you have high pressure gas, which is discharge. But that third line can also double as an extra suction line. So on very hot days where everything's running full tilt in AC, you'll basically have 2 suction lines. Any other time, the discharge line goes inside to be able to provide heat. if heat's needed anywhere, and then your other lines for cooling. You will always have at least liquid and suction, and then discharge or an extra suction. And that makes heat recovery capable of doing heating and cooling simultaneously. So a heat pump can only provide heating or cooling. So the whole system has to be running in heating, or the whole system has to be running in cooling. On heat recovery, you can run simultaneous heat and cooling, except for on very hot days when you probably wouldn't need heating anyway. Your discharge line that would run to your indoor units to provide heating is now switched over as an extra suction line to carry the additional load in the building. Um, so that's the difference. That's the primary difference between heat pump and heat recovery. When you see the piping sizes, what you'll find is the liquid line is the smallest line. The low pressure gas or suction line is the biggest line, and then the discharge or the high pressure gas slash suction or low pressure gas is the medium size line. Sometimes those two lines are the same size, but if one is bigger than the other, the bigger one is your true suction, basically. All right. So again, looking at these units, it's just a basic outdoor unit for the most part. You know, well, I don't want to say that. There's a lot of complicated uh, components to this, but it's basically at its very basic form, just an outdoor unit with some valves in it that direct the refrigerant flow. Just a bunch of valves and sensors and circuit boards. Um, the indoor units, again, you'll see they look very much like mini splits. So, for Daikin in particular, they have 13 types of indoor units, and for the most part, this is standard across all VRF systems. So, one manufacturer may not have the different styles of ceiling cassettes be the same or something like that. But for the most part, you have wall-mounted units, which is pretty common. Not as common in VRF, but pretty common. Then you have your ceiling cassette models. So this under ceiling cassette that they offer that's new, and then your run of the mill ceiling cassettes, a round one and a 2x2 square one. Ceiling suspended units, you don't see these a ton, but you do see them installed now and then in bigger rooms where you want to blow air across the top of a room. This is generally going to be mounted just below the ceiling, but you have a horizontal discharge air instead of a vertical like the ceiling cassettes. Floor standing is a good replacement for radiator style units or water source heat pumps that go along a wall. That's where you'll see these used a lot. Concealed floor standing is the same thing. It's just you make your own outside cover for it so you can make it look different than the standard model. Vertical ducted, they started, if you ever wondered why, just interesting backstory. Daikin bought Goodman. They basically bought Goodman just so that they had a manufacturing facility for vertical ducted air handlers. No lie. I was basically installing these things when they bought them. So when Daikin first started offering this vertical ducted unit, they basically just bought indoor units from Goodman and then converted those to have components that were suitable for VRF. And then I think not even a year later, not much longer after that, is when Daikin bought Goodman and Amana and everybody. They basically bought them just for manufacturing these units and taking over the rest of the product line at that point to make money doing it, I reckon. But Daikin was using Goodman air handlers before they even really bought Goodman. Um, uh, Ducted concealed units, all right. The ducted concealed units, something to keep in mind with all of these, is all of these are pretty low static units. So you need to be very careful with these. These units cannot handle a lot of duct work, but they're just basically horizontal air handlers that hang in the ceiling, and then you can duct off of them. But it's generally a very small amount of duct. You need to be very careful making ductwork changes when installing these units because you can run into trouble real fast where you exceed the available static pressure of them. And then they have outdoor air units and energy recovery ventilators. These things are becoming more common, but for the most part, most engineers will stay away from using the ventilation units on VRF and use dedicated outdoor air units. It's generally considered better design. I don't know if it's still that way. They've been working towards making these work better, but because of the amount of heating and cooling required to condition outside air as it's coming in, this is generally not an ideal application of VRF technology. Because what VRF and mini splits are good at is adjusting the amount of capacity being used at any amount of time, ramping for anywhere from 20% of capacity to 120% of capacity. There's a large range that it can accommodate as far as load to save energy. And when you're talking about outside air, you're generally going to be dealing with something that's always got to be running at a very um, high stage, I guess. And so for the most part, I think it's starting to come around, but for a long time they didn't even recommend these units. Other manufacturers didn't recommend using these because it's just too much on the total system. Even though 8 tons is nothing to a VRF system, it's still a lot of tonnage to not be able to modulate with. Um so single split fan coils. The other thing is, okay, so we've got outdoor units and indoor units. The third component that you're going to see on heat recovery only, you will not see these with heat pumps, generally speaking, but you will see it on heat recovery, is these branch selector boxes. So Daikin calls them branch providers or branch selectors. I forget what off the top of my head what other manufacturers call them, but the third major component basically of a heat recovery system is these branch selectors. And what this does is this splits the 3 pipes coming in to 2 pipes going out. And that was the other thing I was going to cover. Quick digression. All right. Uh so heat pumps 2 pipe. Um Heat recovery is 3 pipe. Mitsubishi does make a 2 pipe heat recovery system. It's the only manufacturer that I know off the top of my head right now that does that, a 2 pipe heat recovery. Uh, 2 pipe heat recovery is very interesting, and if you get a chance to look into it, maybe I'll try and pull up a sheet at some point, but I probably won't. So look up 2 pipe heat recovery Mitsubishi at some point. How Mitsubishi does 2 pipe heat recovery is they actually run hot discharge gas inside with the liquid line. So if you're familiar with steam systems, one pipe steam systems used to operate with the steam riding on top and the condensate flowing back on the bottom. So you'd have this 3-inch steam pipe that provided steam and condensate to units, and the steam would ride along the top of that pipe to the units, and the condensate would flow along the bottom of the pipe back from the units. And it's kind of similar how Mitsubishi does that 2 pipe heat recovery, in that they'll send discharge gas with the liquid line when it's needed to provide heat, and then they just split that. They actually separate the liquid from the gas inside their branch boxes. Kind of neat. I remember reading about it the first time a few years ago, and it's a extremely neat idea. So something to look into if you ever do Mitsubishi um, VRF. I've never actually installed it, seen it operate, know if it does a good job, but it's a cool way of solving the problem of having to run that extra pipe everywhere like you do with heat recovery. But anyway, back away from that digression. If you got a 3 pipe heat recovery system, you're typically not going to be seeing these on a heat pump. Matter of fact, I don't know any application where you see these on heat pump. But on heat recovery, you bring 3 pipes in. So you'll have your line, your suction line, and your high pressure, low pressure gas line. That can be either. And at this branch selector, it's gonna say, okay, this unit is running in cooling, so it needs liquid to it and then suction back. And there's basically just a couple solenoids in here. I think it's three actually. Three solenoids that dictate how this refrigerant flows to and from this unit. Um, if this is running in heating, it'll say, okay, I need high pressure gas to the unit, and then liquid's going to come back. And the only application where you do not need a branch selector box for a unit or set of units, and we'll see what that looks like when we look at piping. But the only time you don't need this branch selector for a individual set of units or unit in heat recovery systems is when that unit is cooling only. Because remember, we always have a liquid line and we always have a suction line. So if we connect this unit to two pipes off the heat recovery, if we just connect it to liquid and suction, it will always be an AC only unit. But any unit that may ever need to run in heating has to have a branch selector box associated with it. But that's the purpose of the branch selector, is to take the three pipes and communicate with the indoor unit and decide which pipes get refrigerant flow. And then your metering device is in your indoor unit. So, branch selectors generally come, and this is kind of similar across all manufacturers. You basically come up to 3 tons, up to 5 tons, for 3 tons to 5 tons, and then up to 8 tons, 5 tons to 8 tons. And that's the basics of the sizes. Generally, there's three, maybe four sizes available on branch selector boxes. That may not be the same everywhere, but that seems to be the common thread on how many branch selectors. So basically, if you have three 1 ton units connected and they're in the same general vicinity, they can be served by one branch selector. Um, the three pipe side is the outdoor unit side because you got the three pipes coming from the outdoor unit, and then the two pipe side is the indoor unit side. And from the nomenclature, real quick, from the nomenclature on these, and this is again pretty standard across the board. Um, you can tell 36 is 3 tons, 60 is 5 ton, 96 is 8 ton. So when you see the model number, you can tell how many tons that branch selector box can carry based on the model number. All right, and then you have the this I really associate with Mitsubishi, and I don't know why, but I really associate these multi-port VRF boxes with Mitsubishi because the most drawings I've seen that utilize this type of box is Mitsubishi. It's a very common way for them to design Mitsubishi VRF. And that is, instead of having a single box for a set of units where they split off the refrigerant as you go to the unit, they'll go into one big branch selector box and have multiple ports off of it. So, with this box, you have 4 ports. So you have 3 ports coming in from the outdoor unit, and then you have 1, 2, 3, 4 ports to go to the indoor unit. So you have the outdoor unit pipes going into the branch selector, and then this can serve up to 4 indoor units off of a single branch selector box. You can still serve 4 indoor units off of these, and again, we'll see a piping diagram and I'll explain it. But this just allows you to connect these indoor units separately, and then there's individual solenoids, so all these units can be in heating or cooling. So these two can be heating, these two could be cooling, or it could be heat, cool, heat, cool. There's separate solenoids in this box for each set of units. And it's just a way of making it so, one, you're not running as much three pipe, you're not installing as many Y kits and things like that, and you're consolidating your piping essentially. So again, I don't have as much experience with these boxes because I haven't installed any Mitsubishi actually. I've done Carrier, Daikin, LG, and I think that's it. But um, but Mitsubishi, I've looked at a lot of drawings on, and seen how they lay out the system. And this is very common, or at least was a few years back, for how they design the Mitsubishi systems a lot is these big branch, multi-unit branch selectors. Um, so that's the other kind of branch selector you'll see. Here it's going through dip switches and stuff. We're not going to talk about that because that's not important. The other thing is your controllers, and this is one thing I'll give kudos to Daikin on. When it comes to these mini splits, I'm sure you guys have noticed this too. You get these crazy controllers. Like, what is all this crap that is on these wireless controllers that come with these mini split and these VRF units? I don't understand it. It looks outdated. It looks like 90s technology. It's ugly. It's confusing a lot of the time. It's horrible. It's absolutely horrible. And I've always hated controllers for mini split systems in general, but Daikin's basic navigation controller that you mount on a wall looks good. I'm sure other manufacturers have caught up. Daikin's the most recent one I've done. I started on Daikin systems. The last system I put in was Daikin. It's been a couple years since I've done the other brands, so maybe they've caught up on their thermostats. I'm not knocking how they operate at all, but I've always thought Daikin's thermostat that goes on the wall or its remote controller um, is the nicest. These are still ugly as hell, but at least their standard one that they try to sell you looks good. Um, it's just a weird thing, I guess. But maybe it's because most of this stuff is Japanese or overseas technology, and what they think looks good is different from what we think looks good. I don't know, but I always hated. I do not like mini split controllers, but Daikin's basic one looks nice. Um, so we're gonna skip over. Well, we can look at this real quick. So, the heat pump outdoor unit, line voltage connections, no big deal. There's controller connections in here too, that I don't see. But here's a good picture of the three pipes, right? The three pipes that come out of the outdoor unit. So again, liquid, high pressure, low pressure, yeah. Oh no, is this a heat pump? No, no, heat recovery. This is what we want. Liquid, suction, high pressure, low pressure. And remember, like I said, liquid is your smallest, suction is your biggest, and then high pressure, low pressure is your medium sized line. Try and remember that in case you ever do a VRF system, because you'll get confused sometimes which pipe is which. And you can kind of try and remember based on this. You still have to be very careful when you're piping it to not get these lines mixed up. But that will help you keep them from getting mixed up a lot of the time if you just pay attention. What's my smallest one? What's my biggest one? What's my medium sized one? So those are the three pipes that come out of it. Now, another quick digression. Some units, some systems, especially older ones, will have a fourth line coming out of the indoor unit. That fourth line is an oil equalization line. And that's for if you've got, say, three outdoor units. A lot of these systems, one of the complicated things about VRF, because it's such a big piping system, and one of the complicated things about refrigerant piping in general is returning oil. Okay. The reason you can't run a 2-ton system with an inch and an eighth suction line is because the refrigerant will not be moving to the outdoor unit. It will not be moving back to the outdoor unit fast enough to properly return the oil to the system. Okay. It's one of the less understood aspects about refrigerant piping, and it's something you should be thinking about. Matter of fact, we probably need to go over refrigerant piping some more in a different class, but um, it's one of the complicated things about refrigerant piping in general. And when you're talking about a large complex system, it gets even more complicated. How do you return oil from, 25 indoor units in a system. So some units have a oil recovery mode that they go into to try and make the refrigerant move through the system at a rapid rate, to return all the oil back to the outdoor unit. Some of them, like if I remember right, Daikin, they just have just the way the system runs tends to return oil pretty well. So they don't have a specific mode that occurs, but you know, the system has a way of making sure that the oil returns. But if you don't install the piping the proper size, um, or um, something like that. I'm trying to think of another example. Or if you have too many offsets in the piping or something like that, then the oil won't return properly. So on older systems, what they would do is they would have a tube that connected from each outdoor unit, and that would equalize the oil level between the multiple compressors. So if you had a 3 outdoor unit system all interconnected with 6 compressors, you need to make sure you have the right amount of oil in all 6 compressors. And you add a lot of refrigerant to these systems when you install them. You don't add any oil. If you're familiar with critical systems like Liebert systems and something like that with semi-hermetics, sometimes you end up adding oil because of the amount of oil that has to circulate through the refrigerant system. All oil ends up circulating through the refrigerant system somewhat. So if it's a long piping run, sometimes you have to add oil to make sure that you maintain a proper oil level in the compressor. And in these systems, you don't add oil to maintain that oil level. So the oil that's in there is all you get to maintain the proper oil level in all 6 of those compressors in our example. So they would have an oil equalization line that went to all 3 outdoor units, so that if there was a lot of oil in one compressor but the other one was running low, the oil would equalize through the line basically. But I guess the design of these things have come to the point such that they don't need that fourth line anymore. So most of your modern ones, and I say modern, most of your ones made in the last 5 to 8 years don't have that extra line, whereas the older systems did. So if you see that fourth pipe, it's just an oil equalization pipe. It's not a big deal. Very rarely are you going to have to worry about anything on that. So those are your basic equipment components. I don't want to get into pipe yet, but you do have branch Ys and stuff for piping that are specific to VRF. So we'll look at that in a little bit. But those are your basic system components of a VRF. All right, so this is actually a commissioning guide. So I want to discuss some of the important installation points that you have when doing VR. Well, no, let's look at let's talk about piping and wiring first. Let's not make it complicated. Let's Before we get into commissioning. Here's a piping connection sheet for Daikin. All right, so let's talk about piping. Remember, you have liquid, suction, high-low gas. All right, liquid, suction, high-low gas. This is a heat recovery piping sheet. And this is one of the complicated things about VRF systems. And it's not that complicated, but it's important to make sure you understand it if you're working on a VRF system, or, even if you're trying to diagnose problems, looking for installation errors that could cause issues. So, again, talking heat recovery, we're going to have 3 pipes. And these 3 pipes have to go from the outdoor units. They will tie together at the outdoor units with these special fittings. And this is where the individual manufacturers get a little different. All right. And I had a better picture. Here we go. All right. So you have these special fittings. So basically, VRF is the only system that I'm really aware of where you will see the piping split like this. So if you look at it, you'll have the units from the outdoor units, the piping from the outdoor units converge together. So they'll come together. So if this is a liquid line, these two liquid lines will come together and then they'll join to continue through the system. And then your suction lines will come out. There's actually three of these. So when you see them write out the sizes like this, in this case, for this example, an REYQ 120 and an REYQ 96 unit tied together, you would have a half-inch liquid line, an inch and an eighth suction line, and a 3/4 high-low gas line. Okay. From this unit, you would have a 3/8 liquid line, a 7/8 suction line, and a 3/4 high-low gas line. And then they would tie together and they would become a 5/8 liquid line. So it got bigger, right? An inch and an eighth suction line stayed the same size as the biggest one, and an inch and an eighth high low gas line. So all three of these lines will be coming out of the unit and then they'll travel to where they need to go as a single set of three lines. So all these tie together at the outdoor unit. They continue, and then you get somewhere where you have to split. And you split with these special fittings. And, in this example, it splits right here. It splits 3/8 and 5/8, 7/8, an inch and an eighth, 3/4, an inch and an eighth. So this is basically your main line continuing. And then this splits off to a single branch selector that serves a single unit. And you can see there's only two lines that go to the indoor unit. So three lines split, serve the rest of the units. This one splits to serve a single unit. Same thing here. The line splits again. So all three lines split. Then you have the three lines go to this branch selector, goes to a single indoor unit. Then you have this splits down here, goes into a multi-port branch selector, and goes to individual units. The other thing that you can do that they don't show, let me see if they show it on the heat pump. The other thing you can do well, no, because the heat pump doesn't have a branch selector. So the other thing that can happen, and maybe we'll see a diagram of it somewhere else, but the other thing that can happen is you can have this unit go into this branch selector, right? And it can split off after the branch selector with two pipes and serve another indoor unit. What that means is that both of these units, if they're served off a single branch selector, all right, both of those units have to be running in heating or cooling. So the whole system can run in heating and cooling simultaneously, right? But the branch selector is what determines whether an individual unit or set of units runs in heating or cooling. So if multiple units are fed off of a single branch selector, then all of those units have to be running in heating or cooling together. So, um, a mistake I'll see engineers make sometimes when they design these systems, and it's not common, but it happens. It's like an oversight basically. But a mistake I'll see sometimes is, serving a couple units that are in about the same area off of a single branch selector, but the one unit is on an outside wall and the other unit is, say, in the interior of the building. So, for those of you who are more familiar with commercial, you'll know that most of your interior rooms are generally cooling only. They don't need very much heat. And most of your outer areas could need heat or cool depending on the situation. Plus, along the perimeter of that building, those units generally need more heating or cooling, whereas the indoor section might not. Um, so what happens is those how I like to put it, and this may not be the right way to say it, but this is how I like to put it. Um, those two areas have different load diversity. Okay, those two areas have different needs. So in general, I don't recommend a single branch selector serving spaces, different rooms, if at all possible. All those units should be in the same room if they're off a single branch selector. If they are going to be separate rooms per se, they should all be the same kind of load. So they should all be on the south wall of the building with about the same, amount of windows and stuff, or at least all on the south wall. All right. Or they should all be on the north wall on the outside of the building, or they should all be on the interior of the building or something like that. You want them to have the same kind of exposure to the sun. You want them to have similar construction, and you want them to have basically similar needs when it comes to heating or cooling. So it's something to keep in mind. But you will see multiple units fed off of one branch selector, and generally that's a good thing. You only need basically every branch selector is one thermostat. Now, you can have separate thermostats off of one branch selector, but the other way to think about it is if these units couldn't be on the same thermostat, they shouldn't be on the same branch selector. Okay? So there's that diatribe. But anyway, you can't have multiple units off of a single branch selector. But what you'll have when you're splitting, no matter what, is these kinds of little Y kits. And when we're talking about these Y kits, okay, what's Daikin call them? Forget what Daikin calls them. I just always end up calling them Y kits. Um, Twinning joints, whatever. So these Y kits are different from manufacturer to manufacturer. Carriers look more like a horseshoe, so it will be basically like uh, a U and then one port coming out of the middle. So it's kind of like this, but a little bit more curved. Okay. So carriers I think about them as a horseshoe basically. Daikin's look like, like this, like we're looking at right here. You have the two ports and it comes out. And if I remember right, LGs look pretty similar to Daikin's, but these things are different from manufacturer to manufacturer. So, um, another tangent we can go on real quick is that they tried VRF style units as early I know of as the 80s, and I think it was York, if I remember right, that was trying to serve multiple indoor units off of a single outdoor unit. And where serving multiple indoor units off of a single outdoor tends to get complicated is trying to get this refrigerant to split evenly as necessary to serve the multiple units. And when York did it, my understanding is, and this is all secondhand knowledge, but my understanding is when York did it, they basically just used regular plumbing tees to separate the stuff. And my understanding of that situation was it just didn't work very well. The refrigerant, whether it was their piping rules that they'd come up with or the actual teas they used or whatever the case was, they just didn't work right. Um, Part of the magic of these VRF systems, the ability to serve multiple indoor units off off of a set of outdoor units with a single set of two or three pipes. Part of how that can happen is installing these Y kits to split the pipe, installing them properly, and using the ones that are required for whatever the situation you're in. And these things are kind of funky, all right? But they work. They work pretty well. But there's some rules you have to follow when you install those, and we'll look at those piping rules. But you'll see that you have this single pipe come in. So this is an outdoor unit one. This is a regular RefNet Y branch. And they come in kits for your gas and liquid, or your gas liquid and your high pressure, low pressure gas. So you'll have 3 Ys in one box. And a lot of times it'll come with a bunch of reducers and stuff too. And you can see looking at this that you have a small connection and then it gets bigger and then it gets smaller again, right? And it comes into this little fitting right here that they braze these other sections to. And then it's this size, then it gets bigger, then it gets smaller and smaller. And it does the same here. It comes in, gets bigger, then gets smaller and smaller. And what you do with these things is you cut this pipe at whatever size you need it. So if this is 7/8 and you need a 7/8 connection, then you cut this Y kit right here and you shove your 7/8 pipe in there and you braze it while purging with nitrogen. Okay. You basically just pick your pipe size off of this. And if your pipe size isn't there, you might have an extra reducer that they shipped you in the bag that you have to tie in. Um, in general, what I get told in these installation classes, no matter what manufacturer I'm dealing with, in general, their rule is if you've got the proper Y kit and you need to connect these two pipes, connect those two pipes basically by any means necessary. So, just because this gets bigger and then smaller is no big deal. Just shove the pipe in and you're good. All right. If you need to go to an even bigger pipe than what you have here, then you'll cut this pipe, put on a backwards reducer, and make the pipe bigger after it. It doesn't matter. In general, I never recommend doing that unless you're working on VRF. Okay. For the most part, you want refrigerant pipe to stay the same size the whole length from indoor to outdoor with single reducers at that exact point. But with VRF, you by any means necessary connect these Y kits but make sure you have the right Y kit because these are going to be bigger and smaller based on the size of the Y kit. So you can't use the wrong Y kit for the wrong tonnage. Okay. And because all this piping is based off the connected tonnage and how long the run is. So you've got to have the proper kits and connections for that particular situation. But, it doesn't matter. Just get A connected to B and you're good to go. So there's an outdoor unit, there's an indoor unit one. They look really similar. Now the other ones you have, and again, this is where you get into the less common situations. Doesn't mean they don't get used. It's just out of all the jobs I've seen, they're rarely spec'd. Is the multi-connection ports that look like regular T's. So what you'll have, if I remember right, this is in I'm not 100% sure. Maybe we'll see and it will get some kind of verification. But if I remember right, this is going to be your suction and this is going to be your liquid. In general, if you're using these on suction, and I remember at one point they said you just couldn't do this on suction, but I think they started allowing you to do it. But if these are on suction, they have to be horizontal. These are on liquid. These all need to be facing down and then running. And I haven't been able to find the video, but one thing to remember when you're installing these Y kits is that um, when you're looking at the rules, all right, let's go ahead and look at the rules real quick so I can explain this. If you look at the rules, this Y kit, it's allowed to be straight vertical down, straight vertical up. So if you're splitting and the pipe is running up, then you can split as long as this thing is perfectly vertical. Again, perfectly vertical, you can split like this. So this would be installing it in a wall or something, right? So if you're installing this in a wall or something, you're allowed to have this vertical. Side note, and you get a lot of these notes. If you ever take one of these classes, you will get a lot of these comments as you're taking the class, and it annoys the heck out of me, but you have to live with it, I guess. It's a nature of the beast. So when I took the original Daikin class, and I can't remember if when I took it again recently, if they had the same comment, but they would say, this is allowed, but not recommended. This is allowed, but not recommended. Okay, if it's not recommended, why don't you say why you say you can do it? Well, because you can. It'll probably be fine, but try not to do it. There's a lot of rules like this you're gonna run into in VRF where it's like, this is allowed, but try not to do it. Why? Because sometimes we see problems. What if you have to do it? Then you have to do it. Just do it, but don't make a habit of it. So in other words, you can do these vertical, but don't do the whole building like this. All right. I'm telling you, you're gonna get tips like that from the techs and the manufacturer's reps for these VRF systems. They'll say, they say you can do this, but you probably shouldn't do it. And one way it was explained to me one time is basically, these manufacturers don't want to tell owners they can't do something. So if they say, "Hey, can I do it like this?" They'll try and figure out a way to accommodate a situation. They try and make these systems as versatile as possible. So there's things you can do that you probably shouldn't. Um, and this is one of those things, at least at one point, that they would say, well, you can do it, but you probably shouldn't. How they generally recommend these Y kits are installed is on a horizontal. And you see how it says plus or minus 30 degrees? It's not plus or minus 30 degrees. This thing should be dead level across for the most part, okay? Um, the little bit out of level it should be is so that both these pipes can sit on the same piece of strut. All right, so it can be a couple degrees out. Plus or minus 30 is technically okay, but it's not really okay. All right, you want these Y kits to be horizontal. And the video that I can't ever find another good one on, maybe I'll have to make one up one day. I'll buy one of these Y kits and make a little video. But a good way to think about it is if water was running in this pipe, would it split evenly as it's running through it? So if water came down here, right, and it hit this joint, it would probably split pretty evenly, right? If water's running up through this pipe and it hit this joint, it would probably split pretty evenly, right? If water's coming through the back of this one, it would probably split pretty evenly. If water's running in here, it's going to want to stay on the bottom and not run through the top. Okay, so you're trying to get gravity to work with you on the movement of the refrigerant. That's the whole purpose of having the rules as far as how these things can be positioned. We tend to forget sometimes refrigerant is this magic thing that's inside the system that we pipe to and from the indoor and outdoor unit. Refrigerant's a fluid, okay? So it's going to behave like a fluid. Um, Anytime we're talking about any fluid from refrigerant to air, they will all behave relatively similarly in a lot of situations, in most situations. So if the water wouldn't run through your piping evenly, then the refrigerant is probably not going to run through the piping evenly. So the best you can do to let gravity and the uh, natural flow of things to help you make sure that things split and go to where they need to go, the better off you are. So just think about it like that. Think about if I installed this and I hooked up a hose to this pipe, would all the water separate the way I want it to separate? You know, Relatively low pressure water is what you want to think about flowing through this, and would it all separate evenly? Um, and that's the big deal with these. And then, yeah, here you go. See gas model and then liquid model. You see the gas model needs to come out horizontal like this, level position only. If it's crooked, right? If this was not even and this was the center line of it going up, matter of fact, I'll even do you one better. Well, actually, snapshot, paste. If this was running like this, right? And the water was flowing through this, what would happen? The water would come in and it would come out this pipe way before it came out of that pipe. That's not what we want. We want it to be level and we want it to split evenly. All right. Here with the liquid pipe, where we even go through an extra effort of making sure that when the water comes in here, and I guess it gets a little confusing here because obviously the liquid's going to favor this one, but because the liquid is going to fill this pipe, it's going to be full of liquid. All right. Since the center line is kind of here where it comes in, all these will fill up evenly. So even if the line is a little bit low on refrigerant, right? If it's a little bit low, you're still going to have a liquid level that fills up these pipes instead of having a situation where, you know, um, it's not splitting evenly. So anyway, those are the rules. All right, you follow them. All right. Now, the other thing about these branch kits, well, let's just start looking at the rules. So those are your basic Y kits, and that's how you split. So if we go back to this piping guide sheet, okay, if you go back to this piping guide sheet, you split, go to everything, split and split. You can't see where it's at. The other thing about putting these Y kits in, is it in here? Okay, yeah, here you go. All fixings. And this is very similar between manufacturers. All the manufacturers have the same kind of rigmarole that they're going to tell you about these things. When you're putting in turns of directions or multiple ref nets, so you got this one after this one, and you see how you make a turn and go down? All fixings, ref nets, boxes, fan coils, and 90s for that matter, turns of directions, all right, changes of direction require a minimum, absolute minimum of 12 inches of straight pipe from bends and from each other, i.e., from ref net to ref net or Y kit to Y kit, right? Note this distance needs to increase if possible. Refrigerant noise is critical. So if you don't have at least 12 inches of straight pipe, think about it like this. You're going to have a lot of turbulence as that refrigerant splits and then splits again and then splits again. You're trying to minimize that. You're trying to get some straight flow before you make another change of direction or something like that. So you need at least 12 inches of pipe there. But because of that turbulence, even if you have at least 12 inches, it's still going to be noisy. We don't think about refrigerant as noisy, but refrigerant can be pretty noisy, right? Refrigerant lines running, especially at high velocity, you can hear the refrigerant flowing through those pipes. Think about listening to it right next to a TXV or something like that. So you need at least 12 inches of straight pipe, and really they tend to recommend 24 to 36 inches. 24 inches is kind of where I always try to be minimum. I never follow the 12-inch rule. I always follow 24 inches. How long has it got to be from here? 24, 24, 24, 24 inches of straight pipe between any change of direction or anything like that. You're looking for at least 24. And if you can go farther, go farther. I mean, typically you're not going to run into a ton of situations where you need to split, then split, then split. But when you do, try and, put as much difference between those as possible, as much space. And then, if you got to loop back to your last unit, it's probably no big deal. As long as you're following the piping length requirements and stuff, you'll be okay. We'll look at what a layout sheet looks like at some point too. But 12 inches minimum, straight pipe between anything, any fixing, ref net, boxes, fan coils, 90s, whatever. 12 inches of straight pipe. You need to make 2 changes in direction. All right. 24 inches straight pipe between them is what you want to do. Minimum 12. Try and remember it as 24. Where was I going to go? I was going to go somewhere else with that. So minimum 12 inches between those. Shoot for 24 is your actual minimum in your head. These rules apply to heat pump and heat recovery systems. It's the same across manufacturers. And basically when we say change of direction, the other thing I was going to say, when we're talking changing direction, we're talking an actual fitting. So, if you're using a tubing bender or something like that to bend the pipe, you can be a little bit more, if you got a 45 and then 45, if you got, I'm trying to say if you need to do this, but instead of doing this, you do this, you put a little bit of a 45, bend the pipe 2 directions and go that way instead, or something like that. It's no big deal, right? But if you're going to bend um, if you're going to bend 290s in it like this with the tubing bender, even though it's a pretty long turn 90, I would probably still try and get as much straight pipe as possible in between those two bends. But basically, tubing benders, if you run all the piping with tubing benders, which you should really be trying to do anyway with these systems, um, then you don't have to worry about between turns so much because it's a nice, longer, smoother turn than, say, an actual brazed in 90. So the other thing to keep in mind with this piping is you want to try and minimize joints and minimize elbows. So anything you can do. I don't care if it's kind of ugly. Okay? if if your pipe's going to be perfectly straight and you're going to have lots of nice neat 3/8 elbows or half-inch elbows in there, you're going to braze a bunch of elbows in there so it's nice and straight and looks clean right up to the unit. You're going to make it look really neat if you braze a bunch of elbows in there, or it's going to be kind of ugly and bend up over and sideways and into the unit. Let it be ugly, bend up over sideways and into the unit, and not have those joints in there that are extra spots you can have a leak, and you'll have smoother, more gradual turns in the piping. Always, 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 when it comes to these systems, it is utility over beauty. Okay, you want a system that works, not a system that's pretty. Okay, that doesn't mean do a garbage job, but that means if you can avoid brazing in a 90 and make it, just kind of bend the pipe to where it needs to go, then just kind of bend the pipe where it needs to go. Um, it's extremely important to minimize uh, potential leaks and changes in direction that increase the overall length. Because remember, a refrigerant 90 basically counts as 5 feet of pipe. So if you add 590s, you added 25 feet of pipe. Whereas if you kind of just bent it where it needed to go, you didn't add any extra length to that pipe. So just something to keep in mind. And then they have rules in between outdoor units that you'll need to keep in mind. We're not going to go through that in detail. I don't know if this is I don't know if these rules are as common between manufacturers. In general, you're not going to have these situations where outdoor units are more than 6.5 feet apart anyway. So it's not that big of a deal as far as their outdoor unit connections. Doesn't mean you don't need to follow the rules, but it just means that it's not as I don't think it's as universal across manufacturers. Again, they supply you reducers and these branch selectors and stuff like that. Use the fittings they give you if at all possible. I've even gone as far before to say, hey, I need a reducer. Your Y kit doesn't fit to my pipe. Can I just use a reducer? And they say yes. I've never had them say no. But in general, do the best you can to always use the fittings that they provide in the system. Why? Because it's the fittings they provide and they're okay to install. If you're not sure, ask the person who sold the system to your company or the person that's trained in your company on the system what you can and can't do if you're not sure. This goes back to following manufacturer's instructions, but do not be afraid to just ask the question. Just ask, man. If you're not sure, it doesn't hurt to ask. It does hurt to have the system vacuumed, done, not working, and now you're in a now you're in a bad situation because you didn't ask a question. Okay. So that's basics on all the pipe. I don't have any slides pulled up on it, but let's talk wiring real quick before we talk about commissioning. Let's talk wiring. Wiring is easy, easy, easy when it comes to VRF. Wiring VRF is simple. Here's the basic rules that apply to all manufacturers when wiring VRF. Basic rules that are required when wiring VRF is you're always going to need 2 wires. Very rarely are you going to need more than 2 wires for communication. We're not talking power here. Power is different from every manufacturer. Real quick on power, generally your outdoor units will get power, your branch selectors will get their own power, and your indoor units will get their own power. Some manufacturers, the indoor unit gets the power from the branch selector or vice versa. Some of them, they're all separate. But in general, you're going to have separate power feeds somehow, some way to all the units. But this is very different from manufacturer to manufacturer. So I don't want to cover it too much. But in general, all these things are going to have separate power sources. It is not like mini splits where the outdoor units feed power to the indoor units. That would be a bad idea anyway. And I think that's why they don't do it, because it's just not feasible to run all these power cables between all these units. So power, we're not going to talk about too much, but that's the basics. They all get their own power. But communication, um, is pretty much the same across all manufacturers except for the type of wire they spec. But for the most part, it is 2-wire, stranded, daisy chain through the system. And what do I mean by that? Okay, so typically what you're going to have is some situation similar to this. You're going to have a wire connecting all your outdoor units. One outdoor unit is going to be the master outdoor unit. That outdoor unit is going to have a communication wire, 2 wires, red and black or whatever, colors don't matter, but basically just 2 wires that go to a branch selector box. And then that wire is going to daisy chain to all the branch selectors. So you'll have 2 wires going to this one, and then those 2 wires will continue and go to this one, and those 2 wires will continue and go to this one, and they just daisy chain on. And then from the branch selector, it'll go from the indoor unit, and then from the indoor unit, it'll go through to the thermostat. Generally, that's how it ends up working out. Now, there can be situations where the thermostat goes to the branch selector. I could be misremembering that. It's going to daisy chain to the branch selector, and then the branch selector can go to the thermostat, or the indoor unit can go to the thermostat. I may be misremembering that. Maybe I'll try and pull up a wiring schematic. But the point is that all the branch selectors daisy chain, and then all the indoor units from that are connected to that branch selector daisy chain, and then either the branch selector or the indoor unit's going to go to the thermostat, and it just makes one long line. It's always going to be stranded wire. It's always going to be 2 wires. And for the most part, it never matters if you switch them up. So if you have, let's just call them A and B. You got A and B terminal on the outdoor unit, and you have A and B on the branch selector, and you have A and B on this branch selector. If you tie A to B to A, it doesn't matter. In general, you want to try and keep those wires the same. So A to A to A, B to B to B. But it really doesn't even matter if you cross them up. It's just DC communication between them. You always do stranded wire, never do solid wire. Solid wire is always going to be a possible breakdown in communication. And you never splice it. It always goes a solid wire, one long wire from outdoor unit to the first branch selector, and then one wire going from there to there. If this wire gets cut, pull a whole new wire from one to the other. Try to never splice the wire. You can get away with splicing the wire, but you're taking a risk, okay? So for instance, I've had to do it before. I tried multiple things. Sometimes putting in like a little terminal block that you can tie 2 wires on as if they're going from unit to unit will work. Sometimes it won't. Sometimes soldering to get them together will work. That's generally your best bet, is if the 2 wires have to be spliced. If your wire got cut between these 2 units and you have to splice it, then your best bet is to twist the wires together and solder them. A wire nut might work, it might not. So basically, when the VRF system, when it communicates between indoor and outdoor unit, or from branch selector to branch selector, whatever, when it's making that communication, all that communication is going back to the outdoor unit. Basically, how it tells which unit it's talking to, because this wire just goes from here to here, then from here to here. The only way the outdoor unit knows it's talking to this box is, at its most basic form, is because it takes longer to get there. Okay, it's a longer resistance from here to there instead of from here to there. So because it knows this box is first and then this box is second in the wire run, it knows which box it's communicating with based on how long it takes it to get there and back. That might not be exactly how it works, but it's an easy way to think about it. So if you got a wire nut in here, and that wire was 5 ohms a second ago, but now it's 6 ohms because it's kind of communicating through the strands, and it's not picking up this. It's not traveling the same distance every time. So you wire nutted them together. You've got this spot where it's kind of, it's not exactly the same every time it communicates. That wiring resistance does not stay exactly the same every time. the system will get confused basically. So you don't splice it because you can't have a situation where that connection isn't perfect all the time from A to B to C to D to E to F to G. So never splice the wire unless you absolutely have to. So stranded wire, generally at least 18 gauge, I think, or 20 gauge, 18, 20 gauge stranded wire, whatever the manufacturer specifically says. It may be shielded, but that's not universal across manufacturers. Um, Two wire communication, um, daisy chained between components, and polarity doesn't matter. Those things seem to be the same across all manufacturers. 18 or 20 gauge stranded wire, um, daisy chained, polarity doesn't matter, no splicing. That is your common theme on wiring. So I think, yeah, actually, let's stop there. That's a good place to stop. We will talk about commissioning and other things on the next class. So that's your class on basic VRF components and piping. What I want you guys to do is if you have any questions, to send them to me so that I can answer those questions. And then on the next class, we'll talk about all the pre-commissioning tips and checking that you have to do when you're installing VRF. We'll talk about pressure testing pipe and properly evacuating and properly purging while brazing, because all these things are extremely important when it comes to VRF. But I want to make that its own class because the more I think about it, the more it applies to a lot of systems, not just VRF, but they are extremely important with VRF. So we'll do that separate. But those are the basic components of a VRF system, the basic rules of piping, and the basic rules of wiring. Let me know if you have any questions before the next class. Otherwise, we'll go over commissioning VRF systems next. Have a good evening.